efficiencies on the farm that minimize labor needs, help us maintain productivity of high quality fruit, and are economically viable. And so there's a lot of ways that we're interested in trying to do this, and we've been trying to address that through a research program. And alternate year systems is one of those tools that potentially we could use to try to reduce our production costs. So what does alternate year production systems look like? So alternate year production systems entails removal of the spent floricanes as well as the primocanes that emerged that year, usually with a sickle bar mower, and then producing your fruit on an every other year production cycle. So you'll have a floricane crop and you'll yield fruit, then you'll grow primocanes the next year, just primocanes, no fruit, and then you'll have another cycle of fruit production from those floricanes. So again, every other cropping, every other year production cycle. And this kind of hopefully helps you visualize that. So we have fruit production one year, we mow our primocanes and our floricanes down, and then we get primocanes only that then grow that year and then produce floricanes and fruit the next year. So there's been some work with alternate year production systems in blackberry, specifically trailing blackberry in Oregon, and it's something that's practiced in Oregon. Wei Yang, Oregon State University berry crop extension agent, communicating with him, he estimates that about 50% of Oregon trailing blackberry fields are grown in AY systems or alternate year systems. When you look at some of the literature dating back to 69 or 79 by Bullock, Martin, and Nelson, what they found is that on average, 2-year yields, you see about a 10 to 30% reduction in yield compared to traditional every year production systems because you're producing fruit on an every other year production cycle. So there's lost fruit with that. Bernadine Strick, she also had done some work with alternate year production systems in the 90s and 2000s, and she just published those results in 2018. And in fields with Marion blackberry at 5-foot spacing, they found that alternate year production yielded 66% of the every year production yield. So again, we're seeing a yield decrease from that lost production. However, because you're having decreased labor costs, because you're no longer having to selectively prune and tie and train, as well as reduce pesticide applications because you don't have to protect the fruit every single year, and as well as the possibility for increased cold hardiness because you just have primocanes when you're just growing primocanes, there has been adoption, and that's why we're seeing about 50% of blackberry fields in Oregon utilizing this production system. When we look at raspberry, we really have not seen a lot of research done on AY systems. The one exception was that there was a study down in Puyallup led by Dan Barney and Carol Miles, and they found that there was an overall decrease in yield in AY systems, but this was done in cultivars and in production systems that's not reflective of what we're doing here in Whatcom County. So there was a need to look at it here. So the objective of our study was to evaluate the economic viability of alternate year production systems relative to every year production systems. And so as I start talking about the project and the data, please take note that I'll refer to the alternate year as AY production systems and the traditional every year production system, which is the grower standard practice, as EY, and you'll see it noted as such in the slides. So what we did in 2015, we worked with a grower collaborator up here in the Linden area, and we established a long-term study utilizing Nika red raspberry. And we had 2 treatments, every year, which is the control, and we had alternate year. And we applied it to 2 700-foot-long rows, and we did that 3 times, so 3 replications. So if you just want to get a visual sense of what it looked like, you'll see here we have 3 blocks, 1, 2, 3. And then the 2 blue bars, that represents our alternate year treatment. That's 2 rows. And then we have 2 every year rows. That's our control treatment. And the reason we did 2 rows per block is to make it easier for the grower to spray. So they have booms on either side. It was easier for them to have both booms on and spray and treat the every year trial accordingly, and then turn off the booms as they're going down the alternate year when fruit doesn't need to be protected. So the AY treatments, they were mowed with a sickle bar mower in December or January to remove those floricanes once they were done fruiting. And then some of the data that we collected include yield. We looked at various fruit quality parameters. We looked at several different primocane growth parameters, so primocane number, primocane height, node number, internode length. And then we also looked at costs throughout this experiment. I'm only going to be presenting on a few of those variables. I'm going to be emphasizing the economic data because that really is the key question we were interested in. Now the production timeline, this field was planted in 2014, so 2015 was really our baseline. It produced a crop for both treatments, and then after that we initiated our various treatments. So our AY treatment in 2016, there was no crop, whereas for the every year production systems, we had a crop all the way through 2019, which was the last year that we collected data. Jumping up to AY, you'll see we have no crop in 2016, and then no crop in 2018. So we have 3 years of yield data for the AY or alternate year treatment. So real quickly, just some of the yield results, what we found out. So we're looking at yield on the y-axis here. This is scaled up to pounds per acre. And then we have our 2 treatments, EY in orange, AY in blue, from 2015 to 2019. And so you can see we have differences when we're in the alternate year production cycle and we're not getting fruit on that off cycle. There's a difference in yield, and we would expect that accordingly. We did see reduced yield in both treatments in 2017, and this was due to late fertilizer applications causing some winter injury in both treatments. But on the whole, you'll see that there's a trend for the AY and the 2 production seed cycles, 2015 and 2019, to be slightly higher. But we didn't see that being statistically significant. When we look at some of our vegetative growth parameters, so this top right figure, this is primocade number per hill. We have similar setup, so year on the x-axis and our treatments. We see on average, you know, there's no statistical effect. Again, you can't see the error bars here, but we didn't see a difference in primocade number per hill. And then when we look at primocade height in inches, what we're seeing here on our y-axis, we're also seeing no statistical difference in our primocane height. So let's jump into the economic assessment. So there are some assumptions that we established, and we worked with growers, and we had a focus group, and we kind of came up with our baseline metrics for comparing these treatments throughout the life of the study. So our assumptions are outlined here, and they're also published in this 2015 cost estimates for establishing and producing red raspberries in Washington State. So you can see we were assuming about a 90-acre farm, 60 of those acres in production. We're expecting the commercial life of the planting to be about 6 years, establishment being 2 years, and full production for 4 years. And then some of the other assumptions just represent standard industry practice for Whatcom County red raspberry. For our yields, we utilize the yields that were based off of our trial that was in the field. And then for our every year, our control, we also used our field results, but we also calibrated it, and we utilized data that was from grower focus groups as well as the growers' yield growth model. So let's first look at cost and revenues per acre. So we're looking at cost per acre here on our y-axis, and then we have our 2 treatments, AY and EY, and we have it spread over 6 years. And so we have in the cost in the histogram bars, and then we have them divided up by fixed costs, variable costs, labor, fertilizer, chemicals, soil prep work, which we just see in the first year, and then the diamonds being the total returns. I've got a limited period of time, so the main take home is that we do see when we're not producing fruit, that was in 2016 and 2018, our cost per acre go down. And a lot of that is due to its reduced labor and some to extent reduce pesticides because we're not treating the fruit because there's no fruit. The other thing too is if you look at the diamonds for the traditional every year production system, we see a return 5 of those 6 years. The 1 year we don't see a return is the planting year. Whereas in the AY system, we're only seeing a return in 3 of those 6 years. So looking a little bit more closely on comparing those operating costs, this just kind of hits home what I mentioned on the previous slide. Here we're looking at cost per acre combined over the 6 years of the study. And so we have our AY treatment and we have our EY treatment, and the color corresponds to the initial slide. So we see AY has overall lower operating cost. A lot of that, again, is due to reduced labor because we're not having to selectively prune and tie our plants. And then there's also a reduction in chemicals and fertilizers. But what we see when it comes to labor, which is really where the difference in operating costs comes from, the labor accounts for 42% of the costs for AY and 48% in the every year production system. So Suzette prepared a partial budget analysis of yield in the AY system. So this is yield of the alternate year production system compared to the traditional every year production system. So what we're seeing here on the left here, these are the returns to the grower. And then these on the right here are the costs that you're incurring with this type of production system compared to the traditional every year production system. So you see we have some of our reduced cost in chemicals, fertilizer, farm supplies, and labor. And then we have our total additional revenue and reduced costs from this particular type of production system. But we do incur costs with this, and that cost is the lost production in that every other year production system. And it's fairly significant. So if we look at the net change of profit, which would be basically the sum here, A minus B, we're seeing that with our assumptions that there's a loss of about $6,000 per acre for the life of a planting if we look at the alternate year production system compared to every year production. So Suzette also looked at the break-even price, dollars per pound, for the different levels of the enterprise cost for the life of the planting, again, assuming it was 6 years. So you'll see the different levels of the cost in both the EY, so every year, and AY alternate year. And in the interest of time, I just want you to focus on the bottom here. And so what this is saying for that the alternate year, every year system is that the break-even price for this production system is about 73 cents per pound. Whereas in the AY production system, it's higher, it's 87 cents per pound. Again, because you have that lost fruit from that every year production cycle. And I just want to point out too, so the prices, we did update the prices for this economic assessment to reflect some of the current prices that we've been seeing here in Whatcom County for the past 2 years. We also looked at the break-even yield in pounds per acre. So it's a very similar setup to the last table. The take home here, if you look down, is that for the break-even yield for the traditional every year production cycle is close to 73,000 pounds per acre, whereas in the alternate year it's closer to 46,000, and that's due to the reduced costs that you're incurring through labor. So in summary, what we found based on our assumptions in this model, that the alternate year production system for Washington raspberry producers is not economically viable when compared to our traditional production systems. The price of raspberries has to equal about 73 cents per pound in the traditional every year system in order to recover the total cost of production based on these assumptions, whereas it's higher, it has to be 87 cents per pound in the alternate year system. The total break-even yield is just under 53,000 for the every year production system, where it's closer to 46,000 pounds per acre in the alternate year production system. Suzette also did some sensitivity analyses to look at if we vary the price and hold everything the same, when does the profit of the AY equal the profit of the every year production system? And so what she found is that you're looking at about 91 cents per pound for the AY system profitability to be equivalent to the traditional every year production system. And then when we vary yield while holding everything else the same too, what we see for the AY profitability to equal the every year production system profitability, you're looking at yield having to be about 73,930 pounds per acre. So for this production system to work, really, market price of the fruit has to be higher, and or the yields have to be increased to make it profitable. I don't want to completely discount AY production system though at this time, because there are some ways that you can manipulate spacing, training, plant number per hill, as well as implementing different primocane suppression practices that could try to increase the yield of the alternate year production system. But at this point in time, it's something that we would recommend as being economically viable based on our data. And I think, for our perspective as a research program, we're continuing to look for other production systems that help growers achieve maximum efficiency and profitability, particularly in these times where labor costs are high and fruit prices are low. So with that, I want to acknowledge the grower cooperators, John Mayberry and Troy Cordes at Mayberry Packing, Henry Bierling, who helped us provide some updated economic data, Chris Benedict, as well as all the technical support in my lab, funding, which came from the Washington Red Raspberry Commission. And so with that, I think there might be time for one question. Oh, see.
I'm just going to offer an alternative hypothesis and maybe something else to dig into with the numbers, and that is you made the assumption that the life of the planting was going to be the same. And I'm not necessarily convinced that that is going to be the case, especially if you are in an alternate year production system. You basically have half as many opportunities for the plants to become exposed to raspberry bushy dwarf virus, for example. So I would expect plants to be longer before they go crumbly. So it might be worth adding another little bit to the analysis there to see how many years longer would a alternate year planting have to last in order for it to be comparable.
Yeah.
Just to answer that question.
Sure, absolutely. Yeah, Michael, that's a great point, and that's something we're working on as we work on some of these data. So absolutely, that could make it a little bit more viable.
My question's in regards to primocane suppression in the cropping year or the alternate year. It looked like the primocane numbers were pretty much the same in every year. You weren't burning the primocanes off the year you were harvesting?
So the year that they were harvested, there was some primocane burning occurring. Yes, there was still primocane burning occurring.
But they'd come back to pretty much the same level? Because like in a renovation year, we burn the primocanes off quite late, and there's very few. I would expect to see similar numbers.
So what primocane burning for this particular study, it was done earlier in the production cycle, so before harvesting, and then they allowed the remaining primocanes to continue growing. No, to my knowledge, there was no late primocane burning in this particular trial.
Lisa, I was curious about the year you mentioned there was winter damage, because I agree with Michael's comments about longevity. So was that a particularly cold year? The reason I'm saying is that in our alternate year blackberry production systems, the year when we have just the primocanes growing, they're significantly more cold hardy that following winter than in an every year production system when the primocanes are growing with competition from the floricanes. So you didn't see that, or that might also really increase production?
Sure. So the question about winter injury, gosh, I think that was like 2017. So yeah, we're certainly familiar with the fact that hardiness should be increased with alternate year production systems. What happened for that particular situation is that there was a late fertilizer application. So I think, there was growth still occurring, and any benefit that they might have obtained from that increased hardiness was lost because of that fertilizer application stimulating growth. So, yeah. Yes.
All right. Thank you.
Thank you.
Thank you.